We're looking at variance and standard deviation for PDFs in this video. So the first PDF we're looking at is rolling a single dice. So you're going to have X and probability that big X equals little x there. And we're going to go 0, well we can't roll a 0, but we're going to start from 1 all the way up to 6. And provided this dice is fair, then these are all going to have probabilities of 1 out of 6. That will equally likely. We also call this a uniform distribution. Okay, so verified that it is a PDF. So there's two things. So all probabilities are positive. Yes, they're all 1 out of 6. And that the sum of the probabilities equals 1. Yes, because a 6 plus 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 a 6 does equal 1. Yes, so that's good. For part B, we're going to find EX. Now, this is technically the last video, but basically what you do is you go all the X values times all the probabilities, and you sum that over everything in your table. So in other words, this is going to be 1 times the 6th, and 2 times the 6th, and 3 times the 6th, and 4 times the 6th, and 5 times the 6th. Now, a lot of people, when they calculate a mean, they just want to add up all the numbers and divide by 6. And that will work in this case because everything's equally likely. But if your distribution is bumpy and they've all got different probabilities, then you have to use this formula. What you get when you do that is 3.5. And I'm also going to verify that. So if we go into our stats list and we just clear off everything, you can actually enter this data as a PDF. So enter it like that. And we can enter 1 out of 6 for each probability. And if we go calc, set our frequency list to list 2, and hit one var stats, X bar is 3.5, and that is E of X. So if you ever see E of X, mean, X bar, or mu, they almost mean exactly the same thing. The only difference is this is the sample, that's the population, but they all pretty much just mean the mean. Okay, for part C, this is where we get the new stuff. Calculate the variance and standard deviation. So there's a formula for this. So basically the formula goes, we'll do the variance first since it's easier. The variance is, all right, so it's the sum of all the X probability bits minus the mean times all the probabilities. And I think you got to square that as well. There's actually two formulas for it. I just like the first one. Okay, so let's see what we get. This is going to be basically what it's going to look like is very much like the previous equation. But the first X value is 1 take, and then the mean is 3.5. We square that, and then we times it by the probability of that, of getting a 1. So that's 1 out of 6. 2 take 3.5 times the probability of getting a 2. 3 take 3.5 squared times the probability of getting a 3, and so on and so forth. And don't worry, there will be a quick way of doing this. 5 take 3.5 squared times 1 out of 6. And 6 take 3.5 squared times 1 out of 6. Now I want to stress those probabilities won't always be 1 out of 6 in every example, but in this example they pretty much are. Okay, so pretty much, I don't know what that is, and I can't be bothered chucking it into the calculator. But I think for the purposes of this video, we better do it. 2.9167, or like 2.916 recurring would be the variance for this one. Okay, now standard deviation is just the square root of the variance. So this is root of 2.916 recurring, and that's going to be roughly equal to whatever the square root of that number is. Let's go with 1.70 or 1.71. We'll go 3 significant figures. Okay. Now I was saying I couldn't be bothered putting that into the calculator. And what I mean is we already knew this. So if we go back into stats, when we calculated our mean off this list using 1var stats, it already told us what the standard deviation was, 1.71. And if you want to find out what the variance is, you can literally take what the calculator said, so 1.707, square it, and you'll get what the variance is as well, roughly. So you will almost never have to do this by hand. Okay, so now 2 dice. First off, I've given you a table for these probabilities, but I've left one intentionally blank, just as a little example of how to approach this. So one way that you can do it, and the way that you'd be expected to do it in like an exam, is you need to use the fact that it's a PDF. So if you actually add up all these fractions, leaving the A1 blank, 4 out of 36, plus 5 out of 36, plus 6 out of 36, 7 out of 36, no, 5 out of 36. The dice goes back down, it's very tricky. 4 out of 36. Anyway, when you enter all this, you get that number, 11 out of 12. So our missing value for A would be whatever makes that equal to 1. So that's 1 out of 12. Or probably just to be consistent, I'm going to write that as 3 out of 36. Cool. All right. So that's how you calculate a missing value in a table like that. If we think in the context of dice, how many ways can I roll 4? Well, I can get a 1 and a 3. I can get a 3 and a 1, or I can get a 2 and a 2. That is 3 ways out of the total number of ways, which is 36. So that's sort of why that probability is what it is. Anyway, let's find these. Now, okay, how you would do the expected value, I'm not going to do the whole thing, but it's 2 times 1 out of 36 plus, let's see, 3 times 2 out of 36, 4 times the A value, so 3 out of 36, etc., etc. And the last term would be 12 times 1 out of 36. So that's what you do if you did want to do it by hand. But I'm guessing you don't because it's a horrible process. So let's put both of these lists into our stat list and see what we get. So just clear out all those. Okay, 2, 3, 4, 5. 12 in there, and we're going to go 1 out of 36 all the way. I didn't want to put you through watching me enter those, so there they are. They're all in the list. Calc set, make sure you got your frequency list set up. 1var, 7 is the expected value. So we'll just tuck that in. Now, if we wanted to do the variance formula by hand, this would be the first y value. So this is 2 take the average, which is 7, and we go to times it by the probability of getting a 2. Then you've got 3. Take the average of 7 squared times the probability of getting a 3, and I forgot to square that last one, plus all the way up to 12, take the average of 7, and it's a 1 out of 36. Nobody wants to do that, so conveniently, well, I'm not even going to type that whole thing in because we know what the standard deviation was from the calculator. It was 2.415. And the variance would roughly be that number squared. So 2.41523 squared gives me 5.83. That would be the variance. So this is how you can cheat it. You'll never have to do it by hand, but 5.83 is roughly the variance. We should use an approximate sign since we approximated that. Okay, now I didn't put it on the questions here, but I would like you to think about what's going on here or what pattern. So for one die, we had the mean and the standard deviation being 3.5 and 1.71. For 2, the mean was 7 and 2.415. Okay. Now, I'm hoping that we can see the pattern for at least the means. I literally just doubled it. I would encourage you to pause the video and see if you can find out what the pattern is for the standard deviation. Okay. If you're familiar with the last topic, if you're following along with these videos exactly, you might recognize this as sum of samples or the central limit theorem. If you're not, that's no biggie. We'll cover it later in this topic. But you have to times by root 2 to get that. And if we check and go 1.71 times by square root of 2, I'm hoping that it's about 2.41. Cool. And for example, if I wanted to do 50 dice, my mean would be 3.5 times by 50, and my standard deviation would be the original one times by root 50, whatever those numbers end up being. So all that central limit theorem stuff does apply to discrete variables as well.